Hello everyone. So welcome back to my channel. In this video, we will discuss about that very famous problem of SDE sheet, which is name is point change. This problem is also very famous for the dynamic programming. Okay, so let us discuss about that problem statement. You have given an integer array. You have given an integer array and their names is points array. Okay, of size n representing different denomination of currency and an integer sum. Find the number of the ways you can make the sum by using different combination of coins array. Okay, assume that you have an infinity supply of each type of coin and you can use any coin as many as time you want. So I'm just understanding you that what happens in this statement. You have given an integer array names coins like here names coins and having an array 1 to 3. Okay, of size n and there is a size which is 3. Okay, and then currency which is the target sum is equal to 4, which have to make that 4, which have to make the 4 by the help of this coin. Assume you have to be infinity number of supply of this coin. Suppose of that if you want to be make a 4 by the help of coin 1, so 4 coins of 1 we can get to to make this sum 4. Okay, so this is our possible way. This is our one way to make this sum. So according to this condition you can make 4 number of possible way you can make that given sum. Okay, so here is the solution, here is the answer. Okay, now let us discuss about another example. You have a you have required a sum 10 by the help of this coin of this size. Okay, so according to this condition you can make that there are the 5 possible ways you can make that sum 10. I hope you have to be understood very well. So let us discuss about that uh, dry run of this example. Okay, so here are the example, and this is an array of this coin having zeroth index and first index and second index. Okay, at second index which have a coin 5, first index coins have 1 and zeroth index coins 2. Okay, so what would be your approach? What would be your approach? So the basic approach is that each of the coin pick each of the coin will be picked or not pick it or not pick to make this sum of this given according to this question. Okay, so you will make a 10. So here are the two solutions. either we will pick 5 Either we will pick 5 or I will pick or I will not pick. So we have a both two options. Okay, so let us try run this approach. And so yes, so this is an array of this index. Okay, and having a sum. You have to make this sum by this help of this coin. Okay, so let us now. If we don't pick it this index of coin, I have already told you that I have a two options at a particular index. If I don't pick it that 5, so what we will do? We will simply move on, which is simply move on index 1. If I will not pick it, so our sum will not be reduced. Our sum will not be changed. Okay. If I will pick it, if I will pick, so what we will do? We will simply reduce our sum and without changing without change our index. Suppose of that if I will pick that 5, so I will reduce my sum by 5 because I need only 5 more to make this sum. Okay, now again we will discuss about that. I have also that two options at index 1, which is I will not pick this coin. If either I will pick this one. If I will not pick it, if I will not pick, so I will move on index 0 and our sum will be not reduced. Okay, if I will pick this coin, if I will pick this coin, so I will reduce my sum by 1. I hope it would be clear to you that what is that our approach. Okay, so here is the base case. Here is the base case. If I will pick, if if I am standing right here at index 0, so I have only a one coin, only one coin which having a rupees 2. Okay, so what we will do, we will simply we will simply make this sum by the helping of this single coin. Suppose can I make this 10 by this help of coin of this infinity supply? Yes, we can make it. We will make a 5 number of coins of coins 2, which will be equal to our sum 10. I hope it would be clear to you. It would be clear to you. Okay. So now now we can simply return that yes, this is our possible solution. This is our possible solution, possible way we can generate, we can make that sum is equal to 10. Okay, so now we will again move that uh, pick part. So if I will, if I will don't pick from this function, that I will again move that index 0 without changing our sum. I hope it would be clear to you. Now again, if I will pick it, if I will pick it, so I will simply move on index. Without moving index, I will reduce my sum by 1. If I will don't pick it, so now I will move on index 0. Okay, if I will pick, so I will simply without changing my index, I will reduce my sum. I hope it would be clear to you what I am applying this logic. If I will not pick, if I will not pick it, so what we will do, we will simply move on index 0 without changing our sum. If I will pick, I will I will return that 1 comma 6. Okay, now again and again function call itself. So this is our recursion. Okay, now again we don't pick it, so I will move on index 0. If I will pick, if I will pick, so I will move with 1 comma 5. If I will don't pick, so I will move on index 0. Now again if I will pick, what we will do, we will simply move on index, simply change my sum. Again I will don't pick. Now I will move on index 0 with sum 4. If I will pick, I will reduce my sum without changing my index. I hope it would be clear to you that what would be logic apply here. If I will not pick, I will simply move on index 0 without changing sum. If I will pick, now I will sorry, I will change my sum. Now again, if I will not pick it, I hope it would be clear to you. Okay, so this is our ending part. Right now I have discussed some more, like, and 1 comma 1. Now here is another having cases like right now. So I have to be required. This is our sum, and this is our index. Okay, so I will require the sum with this particular index. Can I make sum 1 with this particular index 1? No. Yes, we can make it. Sorry, we can make it. So we will simply uh, having a two choices, 0 and 1. 0 and 1. So right now we have to be think about it. So can I, if I will not pick, so I will simply go index 0 without changing our sum. If I will make it, so I will go with index 0 with sum 0. Ah, sorry, without changing our index. Okay, so now they are having some another condition. Can I make one at index 0? Because at index 0 I have only a 2 rupees coin. So can I make this one with at index 0? No, we can never make this one. We can never make this sum at index 0. So I will return 0. So we can never make this sum. Okay, now again, can I make this 0 at index 0, at index 1, at index 1, sorry, at index 1, at index 1 having a point 1, having a point 1. Can I make this 0? Yes, we cannot pick this coin, we cannot pick this coin. So another we have to be take this, uh, we can generate this 0, we can generate this 0. So this is our 1. I hope it will be clear to you. I am just again explaining to you. Suppose you have a 2 rupees coin, 1 rupees coin and 5 rupees coin. You are standing at index 1. You are standing at index 1 and you have a coin 1. Suppose you don't have required this coin. So can you say that I don't have required? Yes, we can. We cannot require this 1 rupees coin. So I will make this sum 0. Yes, yes, it would be true. It would be true. So this function, this overall function, don't pick it and pick it, would be returned 0 plus 1. So because how many number of ways? So our problem demand that how many number of ways you can generate. So the number of ways would be that, like a pick or not pick or not. Okay, pick plus not. I hope it would be clear to you. Pick plus not pick. So pick plus not pick is equal to 1. So it would be returned to the function which is 1. Okay. Now another that would be returned. At index 0 can I make 2? Yes, we can definitely make 2. Definitely make 2. Now at index 0 we have only a single coin 2. So we can generate this. Uh, we can make this sum. Okay. Now this function will be returned 1. So 1 plus 1 is equal to 2. I hope it would be clear to you. At index 0, can I make 3? No. We can never make 3. We can never make 3. I hope it would be clear to you. can never make 3, so this is not our possible way. So 2 plus 0 is equal to 2. Don't pick and pick. Okay, now again we will traverse that. At index 0, can I make it 4? Yes, we can make 4 at index 0, because we have to be required 2 rupees coin into 2, and we can make this 4. Okay, so it would be our possible way, and it is also return 2. So 2 plus 1 is equal to. So again, at index 0, can I make it 5? No, we cannot make 5. So this is not our possible way. And 3 plus 0 is equal to 3. At index 0, can I make it 6? Yes, you can make 6. Make 6, make sense, and make 6. So 3 plus 1 is equal to 4. And at index 0, can I make it 7? No, we cannot never make it 7 at index 0. So this will be returned 0. So 0 plus 4 is equal to 4. Simple. And at index 0, can I make it 8? Yes, we can make it 8. So it would be our possible way. So, and this function would be returned 4. So 4 plus 1 is equal to 5. Okay, at index 0, can I make it 9? No. So this function would be returned 0, and this function would be returned 5. So 0 plus 5 is equal to 5. I hope it would be clear to you. It would be clear to you. So at index 0, can I make it 10? Yes, we can make it 10. So that's why we will return 1. And 1 plus 5 is equal to 6. 1 plus 5 is equal to 6. So this function having a return chances of 6. Okay. So now again our pick part at this condition. Pick part at this condition. Okay. So at index 2, can I make this 5? Can I make this 5? It have either two choices. I don't pick and I will pick. Okay. If I will not pick, so what we will do? I will simply go with index 1 with having some 5. If I will pick, simple. I don't move at index 0, at index 1 with changing of our sum. Okay, so this function would be return 1. Why? Because at index 2 we will simply make this sum 0, or either we can say that we have to be generate some recursion function. Call the recursion. If I will don't pick, so it would be go with uh, 1 comma 0. Okay, so this is our conditional behavior of this. So overall we can say that this function will be returned 1. Okay, so now we have to implement on this. At index 1, can I make 5? They have a two choices. We cannot pick, we will pick. So if we'll pick, so I will. If I don't pick, so I will go with 5. If I will not pick, if I will pick, so I will reduce our sum. Okay, at index 0, can I make it? At index 1, firstly I will don't pick. Okay, and second one is that I will pick. So I will reduce my sum without changing my index. At index 1, we have a two option: pick or don't pick. If I will not pick, I will go with some 3 with at index 0. If I will pick, so I will reduce my sum. If I don't pick, again, so I will simply uh, go with index 0 at with the sum 2. If I will pick, I will reduce my sum by 1 without changing my index. I hope it would be clear the intention what is happening at here. So at index, so I will having a chances. So at index 0 we will move 0th index with having sum 1. At index at index 1 without changing our sum. So here we have to be so that this function is again and again calling. So this that's why we have to be choose that d, because this function is also here and this function is also here. So again and again we have to be applying this. So that's why we will our intuition is to be move on dp. Okay, dynamic programming. Okay, so again we will check that at index 0 can I make it 1? Never make it. I have already discussed about it. So this will not our possible way. At index 1 can I make it 0? Yes, we can make it 0. Why? Because of that without without take this coin I can make this sum. So yes, this is our possible way. 0 plus 1 is equal to 1. So this is our possible way. At index 0 can I make it 2? Yes, we can make it 2. We can make it 2. This is our possible way. 1 plus 1 is 2. Okay, now again at index 0 can I make it 3? Never. We can never make 3 at index 0. So 2 plus 0 is equal to 2. Okay, at index 0 can I make it 4? Yes, definitely make it 4. So this is our possible way, and 2 plus 1 is equal to 3. At index 0 can I make it 5? Never make it 5. So this is our 0, and 0 plus 3 is equal to 3. Okay, and this function is will be return 1, and this function will be return 3. So 3 plus 1 is equal to 4. Okay, 4. So this function would be return 4, this function would be return 6. So overall answer is equal to 10. So there are the 10 number of possible ways we can generate the sum by this help of given array. I hope it would be clear to you. It would be clear to you. So let us move to that our code. Okay, so this is our code. So here I will make that function which is named called f, which taking that uh, as an argument takes coins array, current index, having sum, and our dynamic program dp, and our dp vector dp array. Okay, so at index 0, at index 0, so if it is possible way that is can we can say that we can pick this coin, so we have to be generate this sum. So that's why we have to be check that. So sum, if our sum would be divisible by 0th index, so it would be return true for 1, or false for 0. Okay, so this is our dp sum that it is not equal to 1, so we will simply return our dp array. If firstly we will move with not take, we will move with not take. Okay, so if will not take, so I will return, I will move at index I minus 1, at index I minus 1. Okay, without changing our sum. If coins of I is less than equal to sum, according to my take sum, according to my take, why I will make this intuition? Because of that I have already discussed to you that can I make this sum 1 at index 0? Never make this sum. never make this sum. Okay, that's why that's why we will check that our coins of I less than equal to sum, then I will definitely pick it. Then I will definitely pick it, and our sum would be reduced by this current coin index. Okay, and at the end we have to be store our sum, store our value into this current DP, and return our DP index. Okay, so this is our index part. So, and now we will work with that dp vector. So I'm just overviewing about that. I hope you have already learned about that dp array. So this is our 0, 1, 2. Okay, and this is our index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why we will make this array? Because we have to be we have to be generating that dp array to store our previous value, so we don't have to be again and again call the recursion. Okay, I hope it would be clear to you that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So according to this condition, why we will have to be make this sum plus 1. So they have to be multiple, have to be doubt as a beginner level. So I'm just trying to solve with that. We have to be some, why we will take that sum plus 1, because of that overflowing condition. At the next 10, at the next 10 we have to be store our value at next 10 on this sum. So this is our sum. This represent our sum. This represent our index. I hope it will be clear to you. It would be clear to you. So again we have to be store our value at this current index according to our need. Okay, this would be clear. Okay, I hope it would be clear to you. And now first, so this function would be return a exponential solution. So that's why we will move with that dp array with our for loop condition. Okay, so this is our at index 0 will be return our index, our current sum divided by zeroth of this one. Why? Because of that we will check it. We will check that. We will check that this coin 2, this coin 2 at index 0. Can I make this sum 0? Make this sum 1? Make this sum 2? Okay, that's why we will store at index 0. At index 0 of this current sum. Of this current sum. Okay, of this current sum. I hope it will be clear to you. So this is our sum, current sum. We have to be stored at index 0. Okay. So now again we have to be moved with this, with that index 1 to till I less than equal to n, I plus plus, j is equal to 0, j is less than equal to sum, j plus plus. If I will not take, so I will move that previous of this array, previous of this dp of that. Why? We have to be already discussed about that I minus 1. We have to be previous index. So that's why I would be move that previous of this index. Previous of this index. Okay. Now if I will initially I will take this is equal to 0. If our coins of I is less than equal to j, means of that our coins of I is less than equal to that current sum. Okay, so now we will simply take this coin dp of current at this current index with the changing our coins. Let's revise here that our sum would be reduced by these points. Okay, so this is our simple. So we have to be stored. We have to be stored. I'm just seeing the example that we have to be stored each and every index. Each and every index is represent that dp of index I and index j. So each and every index we have to be stored this value. Store this value. Take plus not take. Okay, and at the end we will return our dp n minus 1 comma sum. Why? Because dp of n is equal to 3, so 3 minus 1 is equal to 2, so dp of 2 j is equal to sum plus 1. Sum plus 1 is that 10. Why? Because of that our sum is equal to 4 at right now of this condition. Sum is equal to that 10 is yes, so sum is equal to 10, so this is our sum plus 1. Why? Because of that representing into that array. So last array of this part we will return this solution, and this would be our final solution. Here I will compile it. Yes, so this solution is also taking some large space. So how we can reduce by this previous and current changes. Okay, we can generate this zeroth of this index name called previous. Okay, and now we will generate that another another array which is having name called current. Okay, name called current. Okay, so each and every time we will uh, that store not take plus take, uh, not take and take. Okay, so and store into that our array of this current index at any of this sum. So here is the solution. And each and every time we have to be moving that another index. So we have again and again generating again and again we have to be updating our current index, and our current would be referred as previous. Okay, now that we have to be changes like some code. Previous would be current, and current would be new of this solution. Okay, we have to be written that. Okay, so now this would be some changing, and no need our vector matrix. This is our large number of space complexity, order of n into m. Okay, so no need about it. Yes, I hope it would be clear to you what our intuition right now, and I hope it would be clear. So dp of n minus 1, instead of I will return dp of previous. So the solution would be yes. So our expected solution is equal to that our solution. Okay, so here is the solution of C++ and here is the solution of Java. So this is nothing will be changing. Again we have to be traverse, and each and every time we have to make the previous current simple store into that previous of index, and store into the current of index. Okay, at the end we have returned our base. This is also working fine. Yes, so we have to be return our expected output is equal to that our output. Okay, so I hope it would be clear to you. If you have any doubts, so please comment on my channel. Please like my video, please subscribe my channel. Thank you.